We are here to discuss circular economy. The reality is daunting, and what we want to do today is, with experts, share some barriers, some opportunities, some reality.
So when we talk about circularity, we're effectively talking about an economy where there is no waste, where someone else's waste is someone else's raw material input. And that's important because at the moment we're using resources in a way that far exceeds the planet's ability to deliver those resources.
E-waste is electronic waste, and it's a growing problem in our market. 4 years ago, it was at 52 million tonnes, and in 2022, it's 62 million tonnes. So it's gone up 10 million tonnes.
We're just using too much stuff too quickly.
In the UK, there is about 25 kilos per person that is e-waste in households. The hordes of mobile phones in drawers and cables and TV remote controls.
The quickest win is recycling and refurbishment. If we could get that back into the system, we could extract the really valuable parts of that kit, then actually we start to replenish flows of really important materials.
I think so many of the challenges that we're dealing with today is because of the way that products have been designed. So our ability to recycle, to reuse, to repair is actually locked in at the design phase. We need to have this systemic approach where we actually look across the full life cycle. So we integrate some of the challenges and barriers at end of life, at recycling, and we think backwards, how can we better design in the first place?
We would actively encourage customers to think about how can we extend the life of that technology. Not everything has to be destroyed in order to make sure that you are safe and secure. There are different ways, such as erasure, which realistically helps us meet those carbon reduction goals, because the longer the technology is in use, the better it is for the environment.
Some things that we've done to kind of tackle that, the routers within our kind of consumer division, no longer do you own those routers. They are essentially leased to you. So when we get those back at the end of contracts, they then go through a whole refurbishment program and then go back into stock to then go back out again as new routers. The embodied carbon of those refurbed devices on average is 90% less than manufacturing brand new ones.
But we didn't want to just stop there. Some of these circuit boards have 25 metals in, and yet today we're only recovering 10%.
All IT and telecoms equipment contains valuable materials, precious metals, gold, platinum, palladium, and also some base metals, copper, zinc, nickel. Traditional methods for recovering those metals involve the use of harsh acids, incineration. Our processes are much more sustainable.
What we're trying to do is move away from that and utilise safer chemicals as well as more green chemicals. So our processes are fully circular, so the liquid that we use at the beginning of our process follows the process all around. We extract the metals from the liquid and it goes back into the beginning of our process.
It is an innovative technology, it's quite a disruptive technology, but it's brilliant because it's all about extracting those rare earth metals and getting them to stay in the system. So n2s will, I hope, show proof of concept that circularity in IT is possible. And I really hope today is the start of a journey of scaling. Circularity offers us the potential to stay within planetary boundaries, to deal with issues such as climate change, and is essential to getting us to net zero.